Good afternoon, everyone. Welcome to the Kubernetes Engine Enterprise Ready Networking session. Today, I will talk to you about why Kubernetes Engine is the choice of platform for enterprise workloads. So a little bit of recap. Kubernetes Engine went generally available in 2015, and Kubernetes was born in the cloud. It was always a very developer-friendly environment, and also the choice of platform for cloud native. What does that mean? Cloud native cares about a lot of things like developer agility, automation, and also having a great experience. Enterprises, they care about all of that and a lot more. Today, I will mention how Kubernetes Engine has gone through that journey of also becoming the choice of platform for enterprise workloads. Now, let's talk about what does it actually mean to be enterprise ready. So in front of you are the 4 pillars of enterprise readiness, comprising of the first one being deployment simplicity. Deployment simplicity is being able to control and manage and scale all your cluster resources seamlessly with enough control. Fine-grained control. Typically, an enterprise would want to isolate their critical network resources from your non-critical ones, but still have the flexibility given to your project admins to create and manage clusters. And I'll talk about how Kubernetes Engine helps you get that. The third being security. Security is a very important pillar for all enterprises. I will talk how Kubernetes Engine ensures that all your request paths, whether it's within your VPC, whether it's to and from the internet, or connecting to other Google services, are secure. And last but not the least, visibility. Of course, it is very important for enterprises to be able to see what is going on within their network. And I'll display how exactly Kubernetes Engine helps you get that visibility, which is so crucial to your deployments. And how all these 4 pillars work together to give a unified experience. Now I'll welcome to stage Brad, who's a lead system architect from Symphony, to talk about his journey with us.
Thank you, Manjot. So just to give you a little bit of an idea of what we experience and who we are, Symphony is a secure messaging platform, secure collaboration platform, really aimed at very, very secure and financial services industry primarily. So we spend a lot of our time talking to some of the most security-sensitive enterprises that are on the planet. So from a enterprise readiness perspective, we certainly, even though we ourselves are a startup, we experience that enterprise readiness need very succinctly. The set of customers that we deal with are cautious of public internet. They want the cloud-native features that Manjot mentioned, the ability to be agile, the ability to be more nimble and less locally expensive. They're running a lot of their workloads on-premise today, but they want to move them to the cloud for all the same reasons that any of the consumer-facing applications have moved to the cloud, but they're cautious and concerned about the security. And so functionally, as we went through this, we started working very closely with the GKE team to become cloud native, to bring that cloud nativeness into these enterprises. From our perspective, the problem with the cloud nativeness was primarily driven around getting the traditional way of thinking about networking solved in a way that we don't have the internet as the problem, which is exactly the opposite of what the cloud is, of course, because the cloud is right on the internet. Everybody knows the internet's between it and the actual users of the work. So functionally, private clusters, very important feature for us. We worked very closely with Manjot and her team to get private clusters accelerated to the point where we could start to use them, keeping all the IP addressing in a private space on the VPC, none of it ever exposed out into the public internet, making the enterprise very comfortable with the fact that they understood where their traffic patterns were flowing and they didn't have problems likely to be affected by even the things we've seen in the news recently, like BGP routing attacks or other things where public internet would have been a problem. So now our enterprises, our largest customers, they don't connect even though they use either a direct connect into the cloud or they use a VPN connection that they trust very succinctly, communicating only over private IPs, allowing for that secure platform that we built to be deployed in a cloud-native way and our customers to consume it. So we really do believe that these features are really important to making it happen in an enterprise-ready fashion, and we hope that your enterprises will start to adopt some of these features as well, with Google being kind of leading the charge on Kubernetes. And I think next, Mahesh is going to come up and speak a little bit more. Thank you.
Thanks a lot, Brad. That was pretty interesting. Thanks for tying up how Kubernetes Engine provides feature sets that meets your requirement. Good morning, everyone. My name is Mahesh Narayanan. I'm a product manager in the cloud networking team working on GKE. Well, just to reprise what we talked about, the 4 pillars: deployment, simplicity, fine-grained control, security, and visibility. But there are so many of us, when we try a new platform, we find that it misses or does not have certain key fundamental features. And our reaction is, what do you mean it doesn't work? I can do that today on my current platform. Well, our hope is, during the course of this discussion, we will show to you how Kubernetes Engine is a great platform for enterprise deployment and help avoid this reaction from you. We have a mixed crowd, so before we get into the different aspects of what enterprise readiness means, let's talk about certain building blocks of Kubernetes Engine. These building blocks will be used to explain other topics in this section, so it will be useful over the next 40 minutes as well. We all know about virtual private cloud. This is the building block of GCP networking. A virtual private cloud in GCP provides a global, fully meshed, and a private IP network. This is in fact the customer's network slice in the GCP network. Within a VPC, we have subnetworks, which provides regional boundaries within a VPC, and they give a location connotation. These two are the fundamental building blocks of GCP, whether you're doing GCP or GKE or GCE or anything of that sort. Kubernetes Engine adds few more networking elements to the mix. Let's talk about those. First among them is the Kubernetes Engine cluster. A cluster consists of nodes, pods, and services. A cluster also has a cluster master, which is the brains behind controlling the cluster. It provides the control plane functionality to manage the cluster. A VPC can have multiple clusters. Nodes are VM instances on which pods are run. The nodes provide compute, networking, and storage resources to the different pods. Depending upon the pod's resource constraints, you can have nodes of different sizes. The node gets an IP and it's routable by default. Pods, think of them as tiny task-specific processes that are running on top of your nodes. A pod gets an IP automatically and is also routable by default. A pod can run one container or multiple containers, such as a Docker container. And when there are multiple containers running on top of a pod, all of them are managed as a single entity, sharing the resources of the pod. Services. A service is something that is long-lived and provides a stable and a fixed endpoints to represent all your pods. A pod, on the other hand, is ephemeral. It can come and go because of failures or scalability. So pods are ephemeral, services are long-lived, and they provide services basically provide an abstraction for all your pods. A good example for services is a load balancer. All this comes together in a flat networking model where VPC is the underlying glue that provides a fully meshed network. And in this fully meshed network, all the nodes can talk to each other, all the pods can talk to each other, and all the nodes and pods can talk to each other by default. The benefits of this model become more obvious during the next few sections. Deployment simplicity. So, one size doesn't fit all, and this is especially true for Kubernetes Engine, for enterprise networking that has evolved over time. So Kubernetes Engine has an interesting challenge at hand, For deployment simplicity, it needs to ensure that it's providing the best practices in networking, in enterprise networking especially, and at the same time, integrate well with an enterprise's on-prem as well as cloud presence. So let's talk about what are the different aspects within deployment simplicity. One is control. First and foremost, customers do not like surprises. They want tight control over all their resources. One way Kubernetes engine delivers this is by having distinct ranges for the different resources. So if you have if the corporate has a policy, mandates a policy where they say the nodes should not talk to each other, but the pods should be able to talk to each other. By having distinct ranges for nodes, pod, and services, it makes it a more intuitive model for you to apply such a policy. You can use a firewall policy to block the nodes, but allow, and the pods by default are talking to each other. This is a much simpler model to implement in your network. Control is also extended in the form of provisioning flexibility. If you're an enterprise customer who has a very intricate deployment scheme, you can either let us decide the addresses for you, these address ranges for you, or you also have the user-defined option. And the user-defined option is very critical for the customers who have a very intricate scheme. Just as how you define an IP in a VPC and you map that to a region through subnetworks, you can create custom subnetworks and map the node, pods, and services in a particular region. This gives you very fine-grained control. This makes the cluster size fungible and also solves the bin packing problem. So forgot to animate this. So in this example, as you can see, since these ranges are different, the nodes, you can apply a firewall policy or a security policy which stops the node from talking to each other, but pods can talk to each other. Centralized management. As more customers start deploying Kubernetes engine, we have seen that one of the most often asked questions from customers is around address management. For certain large size enterprises, IP addresses, even private IP addresses, is a precious commodity. They want to ensure that the scheme that they land on for addressing makes sense, works for them as they scale out in future. So Kubernetes engine solves this problem for the customer by understanding what is being used, where it is being used, what is available, and what is the min-max size for the different resources, right? The other advantage of using other advantages model is that we track the addresses as you grow your cluster, across your cluster. So with this tracking and check, we ensure that there is no address collision as you grow more resources in the cluster, or you grow even your clusters, you grow into multiple clusters. This tracking is done dynamically and at runtime. And it also ensures that not only is your GKE footprint not getting address collision, but even your GCP footprint is not getting any address collision. So if you are building something on GKE, and you're also using certain elements on GCP, let's say a GCE or a load balancer, internal load balancer, we ensure that there is no collision across the two. Integrated networking. So when Kubernetes was introduced, there were multiple models to implement container IP connectivity. Some implemented encapsulated overlay networks. There was network route programming for directing the container traffic. But in both these models, the container route, the networking, was kind of bolted on to the cloud infrastructure, making it less agile and coming up with a list of features that were caveated. With the launch of VPC native clusters and the different resources are now integrated within the Google Cloud infrastructure. All the clusters and the different resources, again, are first-class citizens within a VPC. Now, what that means is features like shared VPC, VPC peering, access to Google services, all are available by default to your GKE applications running on Kubernetes engine. As an example, if you are running, if you're using pods and you are accessing these services, cloud storage, cloud bigtable, over a public IP with VPC native knob, you can now access these services over the pod's private IP as well. It's seamless. Lastly, hybrid support. No Kubernetes engine deployment is complete without providing support for hybrid networking, right? We want to ensure that for easy onboarding of Kubernetes engine, the mechanisms that exist today to make on-prem talk to cloud work seamlessly for Kubernetes engine as well. So with that in mind, Kubernetes engine clusters are transparent to on-prem. We have the concept of cloud routers, which facilitates the communication between on-prem and a GKE cluster seamlessly. You can use the existing VPN mechanism, whether it is cloud VPN or dedicated interconnect or partner interconnect, and connect from your on-prem to the GKE cluster, to the Kubernetes clusters. You can also have very tight control over what gets to talk to whom. So if you want to ensure that from on-prem only certain applications or pods are available to communicate with, again from the help of cloud router and using routing, you can advertise specific subnets between the on-prem and the cloud. With that, I'll hand it over to Manjot. Thank you.
Thank you so much, Mahesh. Now, I will talk about security. You all have a tough job. Security is one of those things which is never enough. And we at GKE believe in having both belts and suspenders. And now I will talk about how GKE tries to ensure that all your surface areas of attacks are covered. We at GKE believe in a layered security model where we cover every aspect and every layer of your deployment that should be secure, broadly dividing it into config time and runtime security, where config time consists of separation of administrative control for your deployments, and runtime consists of private deployments and network security. Now, separation of administrative control, what it enables you to do is typically you would have an organization with an infrastructure and a platform team which would want to control your critical network resources and still have your app or your front-end teams be able to create and manage their GKE clusters. And runtime security. Private deployments enables you to get network segmentation where your backend services, which shouldn't be exposed on the internet, are not. And network security dives deeper, a layer deeper from private deployments and drills down within your cluster to enable you to control your inter-service communication. Shared VPC. I will pick up the first one, which was separation of administrative controls. So shared VPC enables you to map your organizational topology onto your critical network resources. And how does it actually allow you to do that? So Kubernetes solved the problem of enabling you to write your infrastructure as code, but we need to still reconcile your operational security models with that. And what shared VPC does is it enables your critical network resources, such as firewalls and other such resources, to be controlled by a handful of network and security admins. And your project or your cluster admins still have the ability to be able to create clusters within a shared network and not have to deal with things like network and security critical resources. Developers should be able to code, test, and deploy their applications without having to deal with questions of connectivity or firewalls, and shared VPC enables you to do that. So talking about what are the benefits that shared VPC actually gives you, first thing that I've already mentioned is separation of your security and your other and your project admin roles. So typically in a deployment or an organization, you would have your infrastructure teams and your platform teams controlling those network resources and have your project teams or your application teams being able to create and deploy clusters in the shared subnets without having the ability to change those resources. And that gives you separation of roles. Second, sharing of common resources. Isolation is great, but in deployments, you certainly have some resources that you would like to share across all those clusters. And shared VPC enables you to still do that and have that isolation that you require. Third, isolation of data and support for multi-tenant workloads. By dividing your workloads and your teams into separate projects that you can attach to your larger project or your organizational host project, you get isolation of data so as to prevent deliberate or inadvertent attacks that you might get. And fourth, more granular billing. We often hear enterprises wanting more granular billing on a team basis, and by dividing your organization into those teams and mapping those teams to projects that work in a shared VPC model, you get more granular billing. Let's look under the hood. I think this is too fuzzy still now. So you have your organization, and then you have your host project. Your host project consists of your shared VPC network, which consists of a few subnets and all the critical network resources that you want to control. Then you have your different apps teams. You have your apps project, you have your database, infrastructure, and many other teams that you might have in your organization. And what you do is you map all of them to what we call service projects, and you attach all those service projects to your host project. This way, using IAM permissions, you give permissions to your project or your team admins to be able to create and manage clusters within the boundaries of their project without affecting any other team. And you enable the network and security admins to be able to control the critical network resources that you don't want the project admins affecting. And so this enables each and every team to work independently and with agility. Moving on to the second pillar, and this comes under runtime security, private deployments. Private deployments is a very, very crucial factor for a lot of enterprises. A lot of enterprises want to ensure that their Kubernetes engine deployments are within the secure boundary of their VPC. You have, typically you have a multi-tiered application. You have a few front-end apps, and you have a lot of back-end services. And your back-end services, which are not exposed to the internet and don't require public IPs, shouldn't have them. And private clusters enables you to do that. Private clusters enables you to cordon off your control plane and to enable your network segmentation by removing public IPs from the nodes and taking your workloads off the public internet. Second of all, with some of the advancements in our peering capabilities, the communication between your nodes and the Kubernetes master is completely private. And third, using private clusters, you can ensure that you set your control plane to default deny. This way, only things that you trust, only the perimeter that you trust has access to your GKE deployments. And unauthorized access, whether it's to your nodes or to your control plane, is completely blocked. Master authorized networks. Now, with private clusters, you took your nodes and your workloads of the public internet, but you want to be able to manage the access to your control plane in a more fine-grained manner. You definitely want to block unauthorized access, but there might be some trusted set of IPs that you still want to have access to your Kubernetes master. So master authorized networks is the option to set a whitelist on your control plane to have access from your trusted set of IPs, which may be on premise or elsewhere, and can control your deployment. So moving on to network security and drilling down to a cluster. So private deployments ensures that your clusters are secure. Network policy works within a single cluster. Network security with network policies ensures that in a model where you have multiple services within your single cluster, they are secure by being segmented from each other. So let's say you have some vulnerability which affected the front-end services. We want to ensure that your front-end services are compromised, but then they don't affect critical services like billing. And network policies enable you to do that. Network policies are user-defined policies that you set on your deployment, which get enforced in real time. And Kubernetes engine ensures that your network policies, that the network policy that you control, are enforced in real time and to the scale that Kubernetes engine supports. Now, let me sum up all the things that I've mentioned and give you an overview of how we see security. Broadly dividing into config time and runtime, where you get separation of administrative control so that you can map your organizational topology to your network, is using shared VPC with granular IAM roles so that you can ensure that your project admins create clusters but do not affect those critical network resources. Runtime security consisting of, first of all, private deployments, which Brad had spoken about earlier. Private clusters enables you to take off your clusters from the public internet and ensure with master authorized networks that your control plane is cordoned off and gives access only to the trusted set of IPs that you control. Network security achieved through network policies, which ensures that in a microservices model where you have multiple services within your cluster, you control exactly which services can talk to which other services instead of the previous way of having a network level firewall, which gives you an all or nothing. Now, moving on to visibility. Security is obviously an important aspect of all your deployments, and having visibility into what is going on within your network is equally important. I will show how some of the things that we are launching at Kubernetes Engine help you do that. So logging and monitoring are the cornerstones of your deployments. And Kubernetes Engine ensures that you have enough visibility and flexibility to get information about the traffic flow within your VPC. And VPC flow logs enables you to do that. VPC flow logs captures the traffic flow, whether it's within your VPC, whether it's to and from the internet, or whether it's from your on-premises to your deployment, or if you're using a host of Google services. So VPC flow logs ensures that it captures all the traffic flows that are there within your deployment, which you might want to look into for several reasons. VPC flow logs also helps you optimize your network usage and egress, enabling you to better budget for your deployments. Now, VPC flow logs is a raw form of log that you can use to visualize with a choice, with your choice of visualization engine. And we have integration with a host of partners, or you can use Stackdriver. And VPC flow logs also enables you to get network forensics and security analysis to dive deeper into any attacks that you might have experienced or within your deployment. And lastly, it also gives you a real-time security analysis with a 5-second time. VPC flow logs is also flexible in the sense that you can export that information in a very secure manner to BigQuery or to Stackdriver logging, as I already mentioned. Moreover, you might have platforms that you prefer to visualize that log information, and you can use Cloud PubSub to actually export that information out and visualize it the way you want. This is a typical way in which you can visualize information from VPC flow logs, where it captures every single the flows that are there between your nodes and your pods. And you can see here the overall traffic that is flowing through your deployment. You can see things like, well, is it coming from Central or Europe, or which zone or region is coming from? And you can also visualize the busiest machines that you might have. Now, I will call upon Bowei to give a cool demo of some of the features that we just spoke about.
So, hi, thanks, Manjot. In this demo, we'll dig into how a single application spread across multiple teams and responsibilities will map to shared VPC, and really see how shared VPC and private clusters will work in practice to secure your apps. So, suppose you have a multi-tier application that spans multiple teams. In this example, you have an apps team responsible for the front end, exposing the application service to the internet. You have an infra team who manages the back end. Now, for development agility and finer grain resource accounting, you would like each team to be responsible for their Kubernetes cluster. But you have a NetOps team that's responsible for the overall security and network resource management. So the question is, how would you map this to Google Cloud and Kubernetes Engine? So first, we start with the host project, the VPC network, which is owned by the NetOps team. They're responsible for IP assignments, firewall, generally speaking, access, and resource allocation. And they have full control over the networking aspects of the host project. Next, you have the apps team and their service project, and they will be managing the front-end application. Also, they will be managing your users coming in for the internet, hitting the application. Finally, you have the infra team. And now, something to notice is that this infra team also has an additional requirement. They want to keep the nodes in their Kubernetes cluster completely private, but also want to be able to be accessible from the application. So let's dive in and see what this looks like. And whoops. OK, so we have this set up as from before. So let's dive in and see what the shared VPC setup looks like in your Google Cloud project. So as mentioned before, you have a shared VPC host project that will be owned by the network admin. In addition, you have attached service projects for each of the teams. So you'll see an attached service project for the infra team, an attached service project for the app team. Now, let's zoom in on the apps team and what their application looks like. So for the apps team, they're using Kubernetes Engine. And let's take a look at our application. It's a pod running on the cluster. And the services is a load balancer service. But first, we need to open up the firewall for the service. When you're running in a shared VPC environment, you can create these services. You can expose them as load balancer, which you using standard Kubernetes primitives. But it's up to the NetOps team to actually expose the firewall. So let's do that. OK. So this will be done by the NetOps team. They will receive a request, say, hey, I'm creating a service. I want to put it on the internet. And it will be up to the NetOps team to expose the service, which is these two firewalls, that then will expose the Kubernetes service to the internet users. OK, so we opened the firewall. What next? Let's zoom in on the infra team. So the infra team is managing a backend, right, serving a database and other data. Now, first of all, it's a private cluster. So actually, you can't access it directly from the internet as you can with a normal cluster. And you will have to use a bastion host to access the cluster. In the infra side, you have an application running as a pod. And you will also need to open up a firewall between the apps and the DB. They're part of the same VPC, so they're connectable. But you'll have to do some work to open the firewall so that these two can communicate. As you see here, the NetOps team will be in charge of this, and they will open an apps to backend firewall. Finally, let's see these two pieces in concert. So we have the application front end on the right side. We have the infrastructure backend on the left side. And here is our application. So our application is very simple. It says, hello, next 2018. But as you can see, it comes in from the internet, hits the app. The app then queries the backend inside the VPC in a secure way, and then the reply goes out back to the user. OK, so throughout this presentation, we've seen what it means for Kubernetes Engine to be a great platform for enterprise workloads. And I want you to take away 4 things from this presentation. First is that Kubernetes Engine gives you deployment simplicity. So it gives you the tools to control, manage, and scale your cluster resources in a centralized manner. And your clusters will integrate seamlessly with other GCP resources. Basically, everything is connected and part of one VPC. And as you could see in the demo, you have multiple teams, and they all share one VPC. And you can create applications that span multiple teams, multiple projects, but use the same network. Second, we get fine-grained control. And shared VPC enables you a separation of administrative roles so that your network resources are managed by network ops without hampering the productivity of your other teams in creating clusters. You get security. So with Kubernetes Engine, you can make every path and surface area secure with private clusters and master authorized networks. And finally, visibility with VPC flow logs. You get views into all of the flows in your deployment and your VPC. And the one thing I want you to take away is that all of this is integrated in a unified experience for all of your workloads. So thank you for coming to our session, and now we will have the Q&A.